What if the most beautiful light show in the universe was actually a death rattle, giving birth to something even more terrifying? Imagine a star, billions of times brighter than our sun, collapsing in an instant, creating a cosmic entity so powerful not even light can escape. This is the story of supernovae and their incredible link to black holes. From the death throes of giant stars to the creation of some of the most extreme objects in the universe, there is much more to these celestial explosions than meets the eye. Get ready to learn about one of the most explosive topics in astronomy: cosmic firework. When you think of the most mind-blowing special effects, what comes to mind? Maybe the Millennium Falcon flying through the asteroid field or Darth Vader's entrance in Rogue One. Well, the reality is that these pale in comparison to the true king of all special effects, the supernova. In a single instant, these stellar explosions outshine the combined brightness of billions of galaxies. To get an idea of the scale, imagine our entire Milky Way galaxy suddenly flaring up with the brilliance of 100 billion trillion stars. That's a number with 21 zeros, unimaginably bright. For a brief moment, a supernova can illuminate the vast expanse of space like a cosmic firework, visible from Earth as a guest star shining brightly among the fixed stars in the night sky. But these celestial fireworks are more than just a pretty spectacle. They are key to understanding the life cycle of stars and the origins of some of the most mysterious objects in space. And while they may seem far removed from our everyday lives, supernovae actually play a critical role in the universe as we know it, seeding the cosmos with the elements necessary for life itself, the star's last breath. But before the boom, there is a life. Let's go back in time to when our star was just a baby, already millions of kilometers wide. It burned steadily, converting hydrogen into helium and building up a massive amount of energy. But this immense power came at a cost. The star was literally burning through its fuel at a staggering rate, consuming enough hydrogen in a single year to power over 10 trillion homes for the same amount of time. Eventually, the star's core started to collapse under its own weight, crushing hydrogen into helium. As the core shrank, temperatures rose dramatically, igniting helium into heavier elements like carbon and oxygen. But this fusion of elements also generated even more energy, causing the star to expand and cool, becoming a red giant. It was at this point that the star entered its final chapter, realizing that its time was limited and its fate was sealed. The core continued to contract until gravity finally won. The outer layers of the star were blasted outward in a spectacular supernova explosion, leaving behind an incredibly dense core. This was the climax of the star's life, the moment when the laws of physics as we know them were pushed to their limits. In a fraction of a second, the core collapsed from a size larger than Earth to just a few kilometers in diameter, creating an object denser than anything in the universe. But this wasn't the end. The collapse triggered a rebound that sent shockwaves racing through the star's remains. As the waves bounced back and forth, they heated the outer layers of the star to unimaginable temperatures, causing them to explode outward with a force equal to 100 times that of a typical supernova. The result was a brilliant flash of light, visible from Earth as a new star in the night sky. This was the supernova. Supernovae, the cosmic forge. These explosions weren't just a spectacular display of energy, they were a driving force for the evolution of the universe. During the supernova, the immense heat generated by the collapsing core fused elements heavier than iron, releasing even more energy and dispersing these elements into the surrounding galaxy. These elements included gold, platinum, and uranium, which eventually led to the formation of planets and possibly even life itself. Without supernovae, the universe would be a much simpler place with fewer elements and fewer stars. In fact, the dust expelled from dying stars is thought to have played a critical role in the formation of the solar system. So we can thank supernovae not only for the beautiful night sky, but for the very conditions that allowed life to flourish on Earth. But that's not all. Supernovae also served as cosmic standard candles, allowing astronomers to measure distances to other galaxies by comparing their apparent brightness with their known luminosity. These explosions are so bright that they can be seen from incredibly vast distances, helping us map the structure of the universe itself. Not content with just enriching the universe and helping us understand its structure, supernovae even played a role in the birth of new stars. When a supernova occurred near a cloud of gas and dust, the shock wave from the explosion could compress the cloud, triggering the formation of new stars. In a sense, supernovae were not only stellar deaths, but also births, ensuring the continuation of the cosmic cycle of life and death. Gravity's triumph. Now let's turn our attention to the most massive of these stellar explosions. For the largest supernovae, the core collapse did not stop at the formation of a neutron star. Instead, it kept going, collapsing all the way down to a single point, creating a black hole. This happened because the star was so massive that the rebound effect was not enough to halt the collapse. The core kept shrinking until it became infinitely dense, creating an object with gravity so strong that nothing, not even light, could escape its grasp. At this point, the star had become a black hole. To understand how this happens, let's take a closer look at the core collapse. As the core began to shrink, its gravity intensified until it reached a critical threshold. At this point, the escape velocity, the speed required to break free of the black hole's gravity, exceeded the speed of light. Nothing could then escape the black hole's grasp, not even light. The boundary of this inescapable region is known as the event horizon, and it marked the point of no return for anything that crossed its path. Once inside the horizon, the core continued to collapse until it reached a single point known as the singularity. At this point, our understanding of physics breaks down, and the laws of nature, as we know them, no longer apply. The result was a black hole, an object so dense that it warped the fabric of space-time around it. The star had died, but its legacy lived on in the form of a black hole. And this was not a rare occurrence. In fact, astronomers believe that every large galaxy contains a supermassive black hole at its center. These black holes are thought to have been born in a similar way, through the collapse of massive stars at the dawn of the universe. Echoes of the blast. Today, astronomers are working hard to detect and study both supernovae and newly formed black holes. With powerful telescopes like Hubble and Webb, they're able to observe the light from distant supernovae and use it to measure the expansion of the universe. They're also using advanced gravitational wave observatories like LIGO to listen for the faint signals emitted by merging black holes. In the past decade, we've made remarkable progress in understanding these phenomena. Just a few years ago, the discovery of a fast radio burst was traced back to a supernova, providing a rare glimpse at this previously unknown phenomenon. Similarly, the detection of gravitational waves from merging black holes has shed new light on the behavior of these enigmatic objects. These discoveries are just the tip of the iceberg. As technology improves, we're sure to learn even more about the role supernovae and black holes play in the universe. The story of supernovae and black holes is a reminder of the interconnectedness of our universe. These stellar explosions not only shaped the galaxies we see today, but also seeded the universe with the elements necessary for life itself. The birth of black holes, once thought to be a rare occurrence, is now believed to be a common outcome of massive star deaths. By studying these phenomena, we gain a deeper understanding of the fundamental laws of physics and the origins of some of the most extreme objects in the universe. So the next time you look up at the night sky, remember that every star has a story to tell, a story of birth, death, and rebirth. And who knows, maybe one day you'll witness the birth of a new black hole. If you enjoyed this video, check out our other cosmic journeys. Don't forget to subscribe so you never miss out on any new updates. Thank you for watching, and as always, keep looking up.